MAT183 Application of Differentiation, which is Related Rates.
Hello, my name is Miza Hamizah binti Halim.
Hi there, my name is Fara binti Rosli.
Hi and Assalamualaikum. My name is Mohamad Shaffi bin Abdul Wahid.
Hello, I'm Aisha maisara binti Ishaq.
Hi, my name is alia afrina binti Idam Khalid, and you can call me Alia. Introduction. What is related rates? Related rates are rates of change associated with two or more related quantities that are changing over time.
Why we use related rates? Related rates comes in handy especially when we have two related quantities and one of the rate of change is much harder to find than the other one. Besides, related rates typically used to find rate of change of volume, area, radius, height, speed, and etc.
This question is about how you calculate the rate of the water. In the equation, water is poured into conical tank at the 9m cube as -1. The radius of the tank is 4m and the height is 12m. Step 1. Separate dH per dt, which is dH per dt equal dH per blank multiply blank per dt. Step 2. Look at the given info and substitute into the blank space, which is dH per dt equal dH per dV multiply dV per dt. Step 3. Find dH per dV using formula that given, which is V equal 1 per 3 pi r square h. They have two variables, r and h. There's no r because r need to be substituted. Step 4. Substitute R using ratio. First, find R. Next, substitute the R into the formula. Step 5. Differentiate V equal dV per dH. From dH per dt equal dH per dV multiply dV per dt. Next, when H is 4, Substitute the h is 4 into dh per dt equal to 81 per pi h square.
The second problem statement is, if the radius of a sphere is increasing at the constant rate of 2 cm as -1, how fast is the volume changing when the surface area is 8 cm squared? To solve this problem, the first thing you need to do is by listing down all of the information given. The first information is the rate of change in radius of a sphere that is increasing, which is 2 cm as -1. Remember, if the question mentioned decreasing, deflated, and etc., you must add negative sign. In this case, you don't have to add because it is already a positive sign. Next, the question asks, how fast is the volume changing when the surface area is 8 cm squared? It means we need to find the rate of change in volume of the sphere when the surface area is 8 cm squared. Alright, let's move on to the calculation. The first step is you need to separate the dv over dt as shown. Then, substitute dr from the information given into the blank space. Now that we know dr over dt is 2 cm as -1, so it is settled. The second step is we need to find the dv over dr. We can find dv over dr by differentiate using formula of volume of sphere, which is 4/3 pi r cubed. So, dv over dr will be 4 pi r squared. Step 3. We will need to substitute the answers into the dv over dt equation, which is dv over dr is 4 pi r squared times dr over dt, which is 2. And the answer will be 8 pi r squared. We have yet to find the r. In this case, the value of r can be found from the formula of surface area of sphere, which is 4 pi r squared. We also know the given surface area is 8 cm squared. Now, we can find the r from this equation, which is 4 pi r squared equals to 8. And then the 4 pi need to be brought to the other side. R squared is now equals to 2 over pi. And finally, dr is equals to square root of 2 over pi. Now that we have found the value of r, we can substitute it into the dv over dt equation. So it will be 8 pi times square root 2 over pi squared. And the final answer is 16 cm cubed as -1.
In conclusion, even when we only have one information of rate of change, it is possible to find any other harder rates needed in a problem statement. This is helpful in solving problems that only provide us with minimum information.